Good afternoon, everyone. You're all very welcome to the Traditional Homes Pilot Scheme information session. We'll just give just a moment or two to allow people to join, and then we'll go ahead and get started. All right. So again, you're all very welcome to the Traditional Home Pilot Scheme information session. My name is Brian Flax. I am the marketing manager here at KORE Retrofit. Today, I am joined by my colleague and the managing director of KORE Retrofit, Barry McCarron, the group technical director for Ecological Building Systems, Niall Crosson, the managing director of Wain Morehead Architects, John Morehead, and Stephen Farrell, program manager for the Sustainable Energy Authority of Ireland. Today's webinar is hosted by KORE Retrofit, Ireland's first registered one-stop shop for retrofitting. KORE Retrofit offers comprehensive home energy upgrade services and facilitates grant funding for a variety of SEAI grant-funded schemes. Some of you on the call may know me from our sister company, KORE Insulation, which is a manufacturer of expanded polystyrene insulation for the Irish and UK markets. But today we are here to talk specifically about KORE Retrofit and the one-stop shop process as it relates to this pilot scheme. So the webinar today is in collaboration with Ecological Building Systems. They are a leader in natural building products. And the session brings together experts from the SEAI and leading conservation architects to guide you through this exciting new scheme. So Ireland's built environment is rich in history. Approximately 16% of homes built before 1945. These traditional constructions are not only unique in their aesthetic charm, but also play a crucial role in preserving our heritage and reducing embodied carbon. However, renovating and retrofitting these older buildings require a unique approach, balancing energy efficiency with the preservation of character. So today we'll dive into some of the key aspects, discussing how you can benefit and what specific considerations apply to traditional homes. So we've compiled your pre-submitted questions that you would have filled out during the event registration. We've also opened up the question and answer function on Teams today. So if at any point during any of the presentations you have any questions, feel free to drop them into the Q&A, and we will try to address as many questions as we can towards the end of the webinar today. We'll also send around an email post-event for a call for questions. So any that we aren't able to get to today will be addressed after the event, along with a recording of the event and a post-event survey. So we do hope you find the webinar insightful as we collectively move towards a sustainable future while trying to respect Ireland's architectural legacy. So thank you again for joining us today. So we'll go ahead and get started now. So I'd like to introduce Stephen Farrell. He's a program manager at SEAI. Stephen will join us to talk about the origin of the traditional home pilot scheme from an SEAI perspective. So welcome, Stephen.
Thanks, Brian. I'll just share my screen here if I can. And I'll do slideshow from the beginning. Brian, can you hear that there and see that okay?
Yep, all looks good.
Lovely stuff. Come here, thanks. And thanks for the intro, Brian, and it's great to be here today. My name is Stephen Farrell from the SEAI. I work on the National Retrofit team and kind of looking after the traditional homes pilot with my colleague, Siobhan Ward in the SEAI. Just first off, it's great to see, I suppose, the pilot program launched and the interest, and it's kind of marked by the number of people who've linked into the webinar. It's really good to see it. I think it underlines the need for the pilot and I suppose the area where people want to delve into and get more information and avail of the grants that are on offer. We launched the pilot about 2 weeks ago. We're hoping to run to Q1 2026, but ultimately we're hoping to get around 100 homes for a deep retrofit. That older housing stock with the solid masonry walls and so forth. The pilot was developed in conjunction with the team in SEAI, namely Siobhan Ward, myself, and Brian McIntyre. But it was we also collaborated with key people in the market, such as Niall and Ecological Building Systems and John Morehead and so forth, people in the Department of Housing. And it was important to get that external feedback so we could build the needed flexibility into the program. And flexibility, I mean by these are different buildings to modern construction, and they need a different length of time, sensitivities. We're dealing with protected structures, and the slight nuances we need, say addressing windows and the statutory requirements from linking in with the local authorities and the conservation officers, but also the U-value limitations, like the modern forms of construction. You might be bringing a wall to 0.27 of a U-value, but that mightn't be safe and proper when you're looking at an older building. And most importantly, that we open up the door for these breathable insulations that can be installed, that need to be installed on these kind of older structures that need to continuously breathe. So we've incorporated that element of flexibility into the pilot. And John and Niall were even stressing that yesterday when we met up, that needs to be understood by the people listening in. As I said, it's 100 homes in the pilot, and ultimately what we're trying to do is get these 100 homes through a whole house energy upgrade in as much as we can, appreciating that we have to do limited interventions and don't do any harm. So that's kind of an underlying theme also. And ultimately, as Niall was saying yesterday in Ecological Building Systems, this is a time for learning. Okay, so the aim is to have a pilot in place. We get learnings from these 100 or so homes, so we can develop a mainstream program to roll out between now, 2030 and beyond. But it's important that we get the learnings and we get the trades and the crafts built up and prime the market to be able to deliver these upgrades to these 200,000, 300,000 homes. So just on my first slide there, it's understanding the technical aspects, the materials and the products and the associated costs with upgrading an older home. The one-stop shop grants are applicable. So a lot of you should be aware of the one-stop shops, and our grant table is on the website. The pilot will help us review the appropriateness of existing standards. An example there could be the U-value limitations and flexibility that needs to be required to get the industry more and more familiar with the appropriate design and specification and installation considerations, protected structures, liaising with the local authority, engaging conservation experts. Ultimately, all these will be delivered through our one-stop shop service. So we have a panel of 21 one-stop shops on our system, and we've brought the ones that are engaging in the program onto our traditional homes website on the SEAI webpage. So it's important people get familiar with them and get in contact with them. And ultimately, what we're trying to do here is drive towards our 2030 targets and upgrade 500,000 homes to B2 our cost optimal level, and traditional homes are a big part of it. And what underpins a lot of what we're doing is that new publication, that document there on the right that was published by the Department of Housing at the start of the new year. It's an excellent document. I'd encourage everyone to have a look at it and get an understanding of the detail on it. It kind of talks about what a traditional building is, specifying safe solutions, regulations, and importantly, the correct retrofit strategy to be deployed in accordance with EN 16883. In terms of that traditional building professional role, so it's important that people understand one-stop shops are expert retrofitters, but we're also mandating that the homeowner needs to engage a traditional building professional, and you'll see the specifiers there in table 1. So that's a conservation architect with relatively qualified experience in conservation, or an SESI registered building surveyor, or a chartered engineer. So we're bringing that conservation expertise into the equation from the outset. They must meet the qualifications in table 1, which is an extract from the Department of Housing's newly published document. The traditional building professional needs to be involved from the outset of the project, so that they'll help inform the specification and the correct way to address these homes. They must have professional indemnity insurance, and we require them to sign a declaration of works at the end of the job, so confirming that there's proper materials installed suitable for the Irish conditions in accordance with the building regulations. Just so people get an understanding of the application process. So the homeowner living in these older traditional homes, they'll contact their traditional building professional, be it conservation architect, grade 1, 2 or 3, say, in terms of the RAI, and they get a sense of what they need to do. Then they'll engage a one-stop shop, and I suppose the homeowner, traditional building professional, and the one-stop shop will work together to generate kind of a works plan and a retrofit strategy. The one-stop shop then ensures or works with the competent building professional to ensure that the qualification and experiences are there to do the job. The one-stop shop creates the application, the SEAI portal, and they'll go through that whole process, and then the letter of offer is generated. So that's just a quick snapshot of the one-stop shop application process, where the traditional building professional sits in and informs the specification, and then the one-stop shop puts the process through the system, but is guided all the time by the traditional building professional, and there's an inspection role to make sure things are being done in accordance with best practice. In terms of the eligibility criteria, just looking at the, I suppose, the clipboard on the right, for the older homes, traditional homes, we're looking for a pre-BR of B3 or worse. Postworks BR at the end of the job of a B2, and there's an energy uplift of 100 kilowatt hours per meter squared per year. Obviously, measures are installed to meet the scheme requirements, and the traditional building professional must be engaged from the outset to oversee the works and the specification of materials. It's just to stress that point. And I suppose the second bullet point there, and it's been kind of ongoing for a number of years, that there's no grants available for these older homes because breathable insulation materials need to be specified and so forth. So what we said is, in lieu of Irish agreement certification or equivalent, a traditional building professional must confirm they are proper materials suitable for the intended use under Irish conditions in accordance with the building regs. So you're bringing into these breathable insulations into the picture now on the basis that a registered architect signs off that the material selected is a proper material as per Part D of the building regulations and it's suitable under Irish conditions. So it opens up this new range of breathable insulations that's more suitable for these older homes that need to breathe. In terms of the declaration of work, so we'll be asking the traditional building professional who's involved in the project from the outset and involved in engaging with the homeowner in the one-stop shop and overseeing works to sign a declaration of works at the end, just confirming that the works have been completed in accordance with the improved energy efficiency and traditional guidance document published by the Department of Housing there just before Christmas. So I'd urge architects and professionals and installers on the call just to be familiar with that document. It points to the main aspects of upgrading traditional buildings, the sensitivities and the considerations required and so forth. So that just, I suppose, this declaration and the inclusion of a traditional building professional into the whole process ensures that the correct consideration is applied, but it also gets around that need to have products NSEI certified. In terms of the grant levels, some of you are very familiar with these, some of you aren't. As you can see, it's broken down into typologies. Just to draw your attention to the window grant there, for example. We're conscious that a lot of these homes may be protected structures and you're not allowed to do replacement windows. So like we brought in secondary glazing as a measure that can be supported, or glazing replacement. So if a sash window, it's single glazed, that you can come in and upgrade it to double glazed once you have approval from the local authority and so forth. So we're kind of providing that flexibility there. And so on. So you can have a look at those grant levels at your own time. Just a point to note that for the wall insulation, you have cavity wall, external and dry lining, that only one of them is applicable based on the largest meter squared of the insulation type installed, and similar with the roof insulation. In terms of the minimum standards, so this is where we kind of, when we linked in with John and Niall, just trying to get an understanding of what happens out there on the ground and other market players. So I've just done a snapshot of the U-value requirements, say for each measure. So as you can see, attic insulation, we're saying 0.16, rafter insulation 0.2, cavity wall, it's as per our technical specification of 0.36 or 0.35. External or internal 0.5, so we've allowed that relaxation, that flexibility there. Typically it's 0.27 on a modern home, it's 0.5. Then on windows, it's, if the window's replaced, it's 1.4, but if there's secondary glazing installed due to restrictions and considerations, it's 2.4 and so on. So the necessary relaxations have been put in place. But if to see the bullet point there on the left-hand side, if the architect, surveyor or engineer specifies that a higher U value is required, so say for example on the external wall or dry lining, and it's only safe to bring the wall U value to 0.7, that's okay. So we're allowing that, but once it's backed up with design and consideration. We've only set the 0.5 in there as an indicator, but if your U values and any of those elements there come in slightly higher, once it's backed up as part of the design, that's fine. And that's that needed flexibility that we have to bring into the requirements. I just have a little diagram my colleague Siobhan drafted here just to give people a sense of the process. So step one, you engage, the homeowner engages a one-stop shop and a traditional building professional, and they work together. And they consider the retrofit plan in accordance with 16883 and the liaise with the local authority conservation officer as required. Step two there's the whole home energy assessment side of things in terms of what measures are suitable. Step three, you pull together a quote based on the specification informed by the competent building professional. The works are carried out, the grant application is made, the works are carried out, and then the final step, the work is finished to a B2 or better. And in relation to the B2 and the 100 uplift, we kind of understand that the B2 is a mark that we want to get to, but it mightn't be appropriate for a lot of homes to get to a B2. So we'll work with applications in relation to that. We just have to be considerate that certain interventions, lighter interventions, need to be applied. And then step 6 there is that the works are signed off, the declaration of works is signed off. As part of a pilot in terms of trying to learn how things learn from the first 100 homes upgraded, we're just looking to get information. It's just a snapshot of the subfolders that we've set up, trying to get idea of the extra effort required to go in when you're updating a traditional home. So trying to get sense of the skills out there, the certifications, the type of materials that are used, the technical design put in prior to any works. So if you're a part of a project and you're linking in with a one-stop shop, it'd be great and it'd be really beneficial in terms of informing how we go forward if we can get as much of that detail into SEAI so we get a sense of the materials and the tests that are happening beforehand and the cost of this as well. So ultimately all this information will inform a mainstream program hopefully after this pilot, and the scheme will grow from there. So that's just a quick snapshot of the pilot. I hope I didn't run over time, Brian, too much. I'll just pass it over to you there.
No problem at all. Thanks very much, Stephen. That was an informative presentation. So I'm sure there will be a few questions there. So just as a reminder to everybody that's joined us today, if you do want to submit your questions, any that you may have through the Q&A feature, we will have a Q&A at the end. So now I'd like to introduce John Morehead from Wain Morehead Architects. So John will be presenting on the traditional homes pilot scheme from a traditional building professional perspective. So welcome, John. Thanks for joining us today.
There we go. Can you hear me?
Yep.
Yeah, excellent.
Good to go.
And you can see my slides.
I can, yeah.
If I could see the rest of my slides, it'd be good. I'm sure we'll be fine. Okay, we'll just go into it. As a professional, very much welcome this scheme coming about. We do a lot of building physics, and unfortunately we end up getting dragged into a lot of litigation work as well, where inappropriate insulation measures have been done to traditional buildings. I think this pilot scheme is going to discourage that happening and inform better solutions for traditional buildings. So it's very welcome. Apologies now. Here we go. There's a wealth of knowledge out there that's been developed over the last couple of years, Irish-based as well, which is very helpful. So there's no excuses really for the industry not to be aware of what's going on now. And we'd strongly recommend all these documents here and the documents that are identified in the portal and indeed in the Traditional Homes Pilot Programme documentation, that they're reviewed. From an architect's perspective, or indeed engineers or anyone else involved in delivering buildings, it's usually a building formal contract, like say the RAI construction contract. And we already have obligations in relation to how that's delivered. We would have specifications. You would do design reviews when you're coming up with solutions. We would use PASVA's planning package. You have to demonstrate that you're meeting the building regs. And there's, of course, the recent, some call it a burden, others call it maybe discipline of ancillary certification. What's going to happen now is that the one-stop shop scheme will be able to not necessarily seamlessly, but enter into this contractual procedure, and we'll be able to use nominations, subcontract forms, etc., to appoint the one-stop shop and all their expertise, which is very welcome. Seen that already, so I can skip it. One of the major things for the traditional building professional is the definition of proper materials. It's in the documentation. I would suggest you have a look at it. But it is basically relaxing the requirement in funding, in securing funding, to have Irish or similar Agrimo certificates. Many materials used in upgrading existing buildings and traditional buildings do not have such things, and never and cannot have such things. So the ability for a professional to define under Part D of the building regulation what is a proper material is important. Minimum standards of the scheme, in a nutshell, are mentioned there: pre-works less than a B3, which would be standard practice. Post-works greater than or equal to B2, not that difficult if you're clever to achieve, and that is all determined under the BER system using DEEP, which is an asset-based system. But you can do that simultaneously with other design tools to make sure you're achieving the most appropriate and cost-effective solution. Primary energy 100 kilowatt per square meter uplift is also not that difficult to achieve, we're finding. These would be the 10 stages based on the mother standard for conservation works, which is 16883 2017. And in summary, it's a 10-step process. What it does is it brings in the concept of risk review during the design process. Step 5 would be there, undertake risk mitigation measures. And that brings in an area for traditional consultants working with traditional buildings, where hydrothermal analysis, etc., needs to be done, and it needs to be done to the appropriate standard. There's been lots of work done, and even manufacturers issuing condensation risk analysis, which were actually being carried out to the wrong standards. As mentioned by Stephen, 16% of the housing stock is pre-1940s. There isn't really a one-size-fits-all, and every job has its own issues. This would be a great example where there's fantastic joinery, original joinery, some of it from wrecks that were pulled from shore, that need to be maintained. You can see excessive groundwater everywhere. It has lots of issues, and it'll need a particular way of dealing with the energy upgrade. And it's a holistic approach. What you do to the roof has an impact on how you address the wall and how you address the floor. It all works together. What's very important is that you limit expectations. And you have a look at how you can reduce the heat load so that you get an efficient heating system. Remember, what we're trying to do here is we're trying to make these buildings comfortable, reduce their energy demand, and we're heating people rather than heating buildings. We use, again, PHPP for working out where the losses are and what areas we should really try to focus on. We also promote using air permeability testing and thermography at the design stage of the job. Before you lift a pen, basically, go in and find out what is the air permeability, what is the leakage, where are the moisture levels in walls. On this particular picky here on the right, there was some old famous 5 and the likes books from the 70s, which were the cellulose source for some very interesting fungal growth. But that's what you find in traditional buildings when you go to work on them. So you've got to expect the unexpected. When you're doing your floors, it's not so simple just to pop up an existing concrete floor. In this particular case, there was a spring below the floor. So what do you do then? You have to work around, and that means that programs can be impacted upon. You've got to review, risk, analyze, talk to specialists like Niall and people like this in the industry. How do we solve this problem? And then do hydrothermal analysis or whatever that's needed to be done to optimize it. When you're doing floors, you can also deal with radon, and areas with high radon are frequent, as we know. You have to look at perimeter losses if you're looking for radiant floor systems in particular, radiant floor heating systems. And sometimes internal walls can cause difficulty. Some of these walls are built off concrete floors at various stages or have been underpinned. You don't know until you go there. And in this particular case, the entire floor was removed, and again, a foam glass type material was used so that we didn't get hot spots in relation to driving ground-based moisture into the walls. Solid masonry comes in all shapes and sizes, and even when it's masonry, the lambda value of the masonry varies a hell of a lot. And cold bridging that you experience, say, when you're doing conventional construction or the 3-bed semi-D regularly, it's not just at the ring beam, it's everywhere. Internal linings, sometimes they're decorative and are of great value. We had one 1720s building which had its original timber linings, couldn't be moved. So we had to start then looking at, well, we're probably going to have to insulate from the outside. Sometimes you find inappropriate materials have already been used. Location and the existing condition, it's critical that you get it sorted out from a moisture management perspective. And remember, drywall is usually a good wall. This would be a situation where we had to work out what we had, and so we did in situ measurements of the U values to find out what was there. Yes, we understand in deep that they may not be acceptable, but we are using this as a design tool. And you can see there in the bottom left, the stone wall lambda values and what the equivalent U values would be change significantly, whether it's limestone or not. There's more information on its way, again, Irish information specific that we'll all be able to use, and it's being disseminated, I think, on the 3rd of December under the Fab Trads. This is showing a load of conventional material, wall materials, and what their U values were actually measured to be. This is where it all goes wrong. Typical situation: gable wall, not repaired, dry lines, PIR insulations, OSBs, racking boards met certain structural requirements when it went in. I think a U value of about 0.16. And on the right, you see the isoplath graph showing how often the environment within that wall area or at the OSB was in a critical nature or critical situation. And it failed within about a year. So this scheme will prevent this happening, I believe, which is very welcome. Again, another typical job to come across 1850s with an extension to the rear, stripped back. Next thing you find behind that yellow paint and Harling render, you find that we have got some block work where that building had previously been lifted. Not expected. Go back, review, figure out what we had to do. What do you do with the existing floors? This would be an intense retrofit. In went the new floors on a again foam glass material, and walls were stripped back, externally insulated and internally insulated as well, but also all done with moisture management in mind. Gutex wood fibre on the interior and lime renders on the interior, which again can be left as they are. But to do that, you need to do a lot of analysis, and level of detail required to work on these types of buildings is significant. It just shows the eaves detail, again with the external insulation, which was cork in that situation, and then the intermediate floor and how we were able to get the airtight layers working at the intermediate floor, and then what happened when we went down to the perimeter area. Again, all thermally analysed. This would have been some analysis done for working out FRSI values, basically assessing what the dew point figure would be where we were hitting 15 degrees on a 1720s building. And again, the option was to go externally insulated, which solved a lot of issues on intermediate floors, and again, carried on through all the way up into the eaves detail. Roofs. Again, telltale situations or things you might find when you're doing your condition survey. Bituminous felt. It can be an absolute disaster. It's very impermeable, and unless ventilation is extensive, it causes lots of issues. This roof had been re-roofed, fibre cement slates, this type of breather membrane or non-breathing membrane, and there were signs of woodworm already starting to happen. So there was an opportunity here. We had to take off that membrane. We had to get rid of the fibre cement slates to upgrade them. And we said, all right, we'll go for an external insulation system that was moisture breathable. come across other issues doing these buildings, which will impact on how this is rolled out. Bats, and how you can actually, when you have to do the surveys, that can impact on the works, and also when you can't do the works. And it turns out with most roofing works, you've got to do them during the winter months or the winter months. You also have to look at materials, and for instance, in that excellent book, The Improving Energy Efficiency in Traditional Buildings, a recommendation is there that you use a wind mesh behind one of these recommended breather membranes so that the bats don't get tangled up in it and they've something to hang. Windows, do you replace or upgrade? Just because there's funding available doesn't mean it's appropriate. And maybe the secondary glazing option is the way to go, or maybe there might be down along the line, once research is out, for maybe funding upgrading windows, which can have other impacts on upgrading or supporting joinery companies, etc. This would be a project which was 1870s project where the windows were removed. They were going to be actually, when we got there, they were going to be replaced with PVC, UPVC. We were able to convince everyone that no, we could rework them. They were all taken out, stripped where necessary, made good, and put back in. And then we put in a secondary glazing system, which was actually quite cost effective, a magnetic secondary glazing system made on site, about 400 quid a pop. And that got us down to below the 2.4 requirement of 2.16 for a measured U value on site. Other low-hanging fruit you might look at is building services. This would be very typical in a lot of the traditional buildings. Some of them have no jackets whatsoever. So domestic hot water storage, distribution, and generation is a very cost-effective way to getting your energy values down. For a heating strategy, the temperatures in these buildings generally expected to be lower. In fact, making them higher or air temperatures higher just induces moisture in many cases. Remember, again, as I said before, heating buildings, not buildings. Radiant systems are really good. Underfloor can be very effective. Again, from a heat pump perspective, very effective with the low temperatures. And also you're heating, again, with high ceilings, you're heating the people. And you're not inducing more moisture. Low temp rads can be used generally upstairs. But if you can at all, reuse and recycle them too. This would be a typical type of building now. That would be, I think it was 1924 for this pilot program. It would be ideal for it. Again, they couldn't previously get funding for doing a whole house retrofit. And what we're looking at doing here is doing a whole house retrofit. We started by getting an air test, which immediately got us down a notch in relation to the primary energy demand. Instead of the default of 10, it was 6.05 meters cubed per hour per meter squared permeability. We would expect to get down to maybe 3, and the requirement under the DTSS, which is the OSS specification requirements, is 5. This would be that particular building, having done some analysis where we're very minor works to the roof. It already has 300 mil of insulation in there. But on the sloping sections, we have to do a bit of work, obviously. And then on the walls, we're looking at, again, a breathable wood fibre or cork insulation, taking out some of the floors, the existing concrete floors. And you can see we're already getting down into the B zone very fast. The introduction of the heat pump makes a huge difference. The top graph on the left there is generated by PHPP, which would be our design tool, and that on the bottom left then is from data which we would run through the Deep 4 analysis, and we'd use Deep in the spreadsheet format. But you can see how the walls were the item in the existing project that were generating the most heat loss. So we had to do something with it, but the externals in this building didn't enable us to go and just replace everything cost effectively. So it was, and this is the sort of thing that, you know, the parameters that come in and inform what you're actually doing. Adjusting the infiltration, air leakage, you can see from the existing to the proposed, there's a significant reduction in the overall energy demand. Again, just a comparative again using Deep, the existing, the proposed with space heating. Reduced significantly, and water heating again significantly by putting in properly insulated facilities or systems, should I say. Again, ventilation, when we tighten up the external envelope, ventilation is absolutely critical. This project would be using demand control ventilation rather than heat recovery, just from a cost and difficulty in delivering ductwork issue. So if you tighten it all up, obviously you've lost what you had before, which was natural stack ventilation through chimneys, where you had the original buildings heated by using chimneys and radiant heating, which is the fireplaces. You can see the heat load index gets down very quickly as well, down to reasonable levels. It gets down to a D1 once the walls are done. I mean, it's a significant improvement from where we were. The outcomes and what we see with this whole scheme, we see the industry is going to be able to embrace significant resources and the research that's available. It's really timely and it's really dense, and a lot of it is Irish stimulated, which is fantastic. It'll encourage the use of suitable materials and practices and stop what I showed you, this sort of, dry lining, which is not a win-win. Not only does it cause mold, it leaks like a sieve, and our airtight studies would show that dry lining is generally hasn't been working, whereas dry lining straight onto the wall with appropriate products can do so. It'll promote quality in every which way. It'll support, and we hope, the rebirth of the traditional skills industry. The amount of joinery shops that have closed down over the last 3 or 4 years is shocking, and they need to be supported. We need to get youth back into this because we need them to be able to do these upgrades cost effectively. Education is already very much out there, and as a result of maybe the last 5 years of programs with TUD, etc., their masters in energy efficient design, which we were involved in, there are quite a number of people who have the skills to do the analysis now. We would hope that the learnings will be fully disseminated and learned from and fed back into the system so that we can future-proof what heritage we have. We've lost so much of it. It's really important we look after what's there. And I suppose most importantly, we've now access to grant support for these types of works for our clients. That's it. Thank you.
That's great. Thanks very much, John. A very informative presentation there, and I'm sure there'll be questions. I think we are having a bit of an issue with the Q&A feature on Teams, unfortunately. So just before we move on, I just want to share my screen quickly here. So if you're having issues submitting questions through the Q&A on Teams, if you want to email marketing@koresystem.com, we can address the questions at the end. If you are submitting a question by email, maybe if you could just put the presenter, the speaker that you're addressing the question to as the subject, and we will try and get to as many of these as we can. So I'll leave this up just for a moment. And thanks again, John. So I'd like to now introduce Niall Crosson from Ecological Building Systems. Niall will give us a brief presentation on some of the materials that can be employed for use in the traditional homes pilot scheme. Thanks for joining us, Niall.
Thanks, Brian. I'll share my screen now. Can you see that okay?
Yep, looks good.
Yeah, good stuff. Okay. Right. So today I'm going to just look at compatible solutions for historic structures. Just a brief background on our company and our own background. Our company, Ecological Building Systems, are based in Athboy, County Meath. Our parent company is called McCarron Byrne. It's a family-based company that was established in 1906, and over 120 odd years became a major importer of building materials to Ireland. I joined the company when it started as an engineer. I was the first employee with the company in the year 2000. And since then, we've expanded considerably with over 20 people in Ireland. And laterally in the UK, we've around 25 people based in Cumbria. And our company really is focused on training, education, and supplying solutions that are based on more bio-based and sustainable solutions, ranging from airtight systems, wood fiber board, calcium silicate, lime plasters, insulating lime. Grass insulation is one of the newer natural fibers we brought in, and hemp and other good stuff like that, as well as natural paints and ventilation systems. So just moving on what John said, a lot of what John said, really I could repeat, but I'm going to skip some of these slides. But in Ireland, the key point that we need to address and be mindful of is moisture, because in Ireland, we've one of the most exposed climates in Europe. You can see in this map, the blue area shows a very severe area, whereas the grey area is severe, and the small yellow area around the Pale, around Dublin, that's the moderate area. So we need to be just mindful of the solutions we supply and use and install, and be aware of the context of the building. So when you're renovating your home, think about its setting, where it's located, how exposed it is. A lot of people are stripping plasters from walls and exposing stone. We need to think about how we, whether that's a good idea or not, or whether we should replaster with a suitable lime to give that wet water and water protection. Because a dry wall is a warm wall, whether you insulate it or not. Moisture protection and appropriate materials is key. And then coherence. Look at a coherent strategy. So when you renovate with insulation, consider the ventilation strategy, window upgrades, and other areas as well. So a whole house approach is central. And that's why I think this pilot scheme, I'm really positive that it does look at a whole house approach, not just looking at one single issue, which can lead to unforeseen risk. And then have caution. Look at the solutions that are out there. There are many different solutions, but identify risk on the project, whether there's moisture risks or otherwise, and ensure whatever you decide to use is compatible with the building. And then build in a degree of capacity. What I mean by that is if something were to go wrong in the future, that the solution does have a degree of resilience, that if moisture gets in, it can dry out and it's redeemable. And that's the beauty of a lot of lime plasters, insulating plasters with lime, or some of these materials. If moisture were to get in, while it's not ideal, if you address the moisture source, a lot of these materials are quite resilient in that situation. So about 90% of all building failures can occur due to moisture. It's been often repeated, and ill-considered retrofits can lead to moisture issues. So that's the key in Ireland, making sure we address moisture either from the outside or the condensation risk associated with inappropriate solutions. And what sets traditional buildings apart from many modern buildings is that they do not have a cavity. Like you see in the top of this slide, a cavity wall, that cavity separates the exterior environment from the inside. Whereas at the bottom of this slide, a traditional wall, typically brick, rubble, stone, or otherwise, they're solid walls. So you have direct contact between the outside climate and inside. And this is a key reason why we have to be more sensitive about the solutions we use. Many modern insulation materials are designed to be impervious, designed to repel moisture. But when you put that on the inside of many of these walls, or externally in some cases, that could lead to moisture accumulation within the fabric. Because without the addition of a cavity, you're relying on the material's ability to allow absorption and drying out occur on a cycle. So this is where a whole house approach seeks the best balance, as this guidance document from English Heritage states, looking at improving building performance, reducing thermal bridging, using appropriate insulations, and incorporating a ventilation strategy that's effective, combined with better draft proofing or airtightness. If we look at traditional walls, historically, they were in a constant cycle of absorption and desorption. But as this illustration shows, if we apply impervious cement plasters and inappropriate paints internally, this can lead to moisture accumulation within the wall over time. So on top of that, using inappropriate internal wall insulation can lead to this issue of interstitial condensation or moisture buildup within the fabric, leading to mold and other health issues as well. On the right here is a farmhouse I visited in Cavan about 10 years ago, where there was a dry lining on the inside, and you can see it was quite shocking, the level of mold and issues that occurred. So that was stripped out and it was replastered with a cork lime insulating plaster internally as the remedial work. So when we're looking at these walls, it's critical that we maintain water goods, have good drainage and so on, but also ensure you're allowing evaporation or breathability as well by using suitable plasters or paints, and ensuring you've good maintenance of water goods, because something that's come into the mainstream more recently in modern times is zero maintenance solutions, but that does not exist. Every building, whether new or old, needs to be maintained. So maintaining water goods, maintaining paint on the outside, drainage, and so on. These are all critical. This has already been referenced. If you don't have it already, I'd strongly recommend downloading it and reviewing it. It's an excellent document. It's very comprehensive, and it's the basic guidance that the SEAI are using for strategies to renovating traditional buildings. John already referenced hygrothermal modeling, and this is a program called WUFI, for example. There are other variants. I've been using this software for about 20 years now, and it's a really useful analytical tool, desktop analysis tool for assessing moisture risk and humidity, condensation risk, and heat flows directly through walls for every hour of every day. So this is really should be the go-to tool for assessing condensation risk in historic buildings, especially when you're applying internal wall insulation on solid walls. And as John mentioned already, the libraries within these software programs are expanding more and more. You can see here, for example, the cork lime, Diason cork lime plaster. That's all within this the software now. It's preloaded, among others, as well as Irish materials and stone through the FabTrads project. In the next iteration of this program, I anticipate it will include Irish stone and brick. So now just looking at some solutions, I did mention about wall prep. That is key. So before you apply any internal solution, whether it's a solution we provide or someone else, these are basic rules and guidance points to investigate damp before it's insulation's installed. Because if you have a wet wall already and there's existing damp issues, even if you insulate that with breathable materials or capillary active materials, if that damp continues to penetrate the wall, this is going to exacerbate, and in the longer term, it's going to raise its head. So before you commence even, it's important to strip back, if needed, impervious materials. And on our website, we have a 5-page guidance manual, which is available for free on our website, which is generic in its content, but very useful, and I'd highly recommend for guidance on preparing walls prior to retrofit. So removing glossy paints, gypsum skims, these materials, in particular if you're applying internal wall insulation. But note, if you have a good lime plaster, it's an excellent material, and for the heritage and conservation point of view, you should try and save as much as possible and do as little as possible, but as much as needed. And so if you have historic lime plasters that are in good condition, we should also be careful and consider retaining them as well. So in terms of internal insulation on solid walls, I'm going to go through 3 basic options here that I see quite often. One is using a wood fiber board, such as Gutex wood fiber, using a mineral-based capillary active insulation like calcium silicate board, or like Calcitherm, or insulating plasters like diathanite, or a timber stud where you have appropriate conditions and you can apply a natural fiber insulation and intelligent membranes. So this is just an example of a rubble wall with internal wall insulation, where we've leveled the wall with an insulating plaster like diathanite and cork lime and bonded wood fiber to that. And then we finish it with lime and a natural breathable paint like Oro, for example. So that's a system called Retro Eco Wall as an internal insulation system. And here we can see it being used on some projects. The next is this calcium silicate board. It's called Calcitherm. And again, this is an internal wall insulation onto a level wall. And then it's finished with a lime skim and a natural breathable paint like Oro natural breathable paint, for example. So that's another internal wall insulation system that's highly capillary active and mold resistant. And here it's used on a Georgian building in Dublin, the Dublin Civic Trust headquarters on Ormond Quay. And then we have the thermal plasters. They can be applied externally or internally, and there's a whole array of different forms of thermal plasters on the market. These are just 2 from the Diason range. This is Evolution or Diathanite Thermactive, and they're applied directly onto stone or brick. And the beauty of thermal plasters is they're very consistent with old walls, very compatible, and you can really attain aesthetic continuity from what was historically there before, and you can replace it with a material that's very similar. They're very capillary active, so they're very absorptive. They can transport moisture away and let evaporation occur rapidly. So capillarity is key, and these have that feature. They're very low in conductivity, very mold resistant, and quite easy to work with from a handling point of view. We do give guidance and training on a lot of these materials, and plasterers really like this material from an installation point of view. It can be spray or trowel applied. Here we can see it's spray applied on this project, for example, on the inside of an old barn building. It's finished with a lime skim, that Dyson supply called Ergotherm, and then it's finished with a breathable paint in the end, like Oro natural clay or lime or mulching paints. You can see the aesthetic you can achieve. So we've worked on projects that achieve passive house levels of air tightness, where plaster straight onto stone. If you even lime plaster straight onto stone, once you plaster stone, it's a very airtight material, but then you have to ensure you have adequate ventilation in the building. So this building has been renovated, and it's achieved exceptional performance with pretty low levels of application of plaster. So here's just a few project examples. These are quite nice vernacular buildings. This is a project by Karen Brownlee Architects, which used the diathanite plaster externally. Won an award with the RIAI in 2023. You can see how you can marry in with the lime thermal plaster, the vernacular features of this cottage, and while still retaining breathability as an external insulation. This is a project in 2019. It's a project in Carlow where diathanite thermal plaster was applied on the outside, so the cork line was put outside, and the inside had cement and was gone into poor condition, and they applied it internally too, and it's stood the test of time very well, and it's performing exceptionally well as well for the client. And also in roofs, you can't forget them. John's already referenced them. There's many different solutions where you can employ a lot of these breathable, high performance insulation materials, which are technically very compatible with historic buildings, as well as in floors. On our website, for example, we have a full installation guide and comprehensive guidance for the restoration of suspended floors. And here we can see a project by AirZeal, who installed a system in Dublin, for example, step by step, making significant energy improvements on the building. And finally, this project I thought is it's relevant for today. It's a building in a protected area in London, actually, and it's by Bob Pruitt and Pruitt Bisley Architects. And we carried out some hydrothermal modeling at the design stage, where he applied 5 centimeters of 50 millimeters of the diathanite thermactive internal insulation on this wall. And it reduced the U value from about 2.1 to about 0.54. So we can see it's quite a considerable improvement. It's not super insulating by any degree, but very close to the levels that the pilot scheme are referring to in terms of backstop U values. And based on hydrothermal analysis, which I won't go to in detail here, but looking at moisture levels within the wall and humidity levels, it was outputting very safe values from an overall moisture risk aspect. But critically on this home, the homeowner had monitored their energy use before retrofit, and you can see the energy intensity was very high. The annual energy use was exceptionally high. But post retrofit, when they monitored energy use, just based on fabric performance, this is using 5 centimeters of the Dyson cork lime, improving air tightness, combined with better windows, they achieved an 80% reduction in energy performance. So that's quite exceptional. And then on top of that, once they put an air-to-water heat pump, they reduced the overall energy use by 95%. So they're not going in invasive, locking in huge volumes of insulation here. It's looking at a whole house approach, utilizing suitable materials, but executed very well. So to conclude, hydrothermal simulation is absolutely key. It's a useful tool, and people like ourselves can carry out these assessments, but John Morehead and similar consultants should be consulted as the trusted professional to carry out these assessments as part of this process. Unrendered walls carry higher risk, so if you can retain plaster on the outside of walls, I'd always recommend that, and a suitable lime plaster at that. But where walls are exposed, there are ways and means of improving pointing and adding breathable treatments to walls to reduce their absorptivity if needed. Very thin walls are more prone to moisture issues, so look, being very careful with them. And I wouldn't recommend using these vapor control layers or vapor barriers if you have a wall that's exposed plaster or exposed brick or exposed stone, and then adding vapor barriers inside. In them cases, I would recommend very moisture open systems like the calcium silicate or the diathanite. But where these membranes are used, and they do have a use, ensure they're intelligent membranes rather than vapor barriers, as referenced in the guidance documents, that they do allow some degree of breathability. And careful wall prep is key, and the installer should receive adequate training. That is absolutely central. So employing people that are recommended by suppliers who have the skills and also the experience. And also it's wonderful to see SPAB, the Building Limes Forum Ireland, and numerous heritage bodies now, the Irish Georgian Society. They have excellent lists of very well qualified and experienced people with this heritage building. So they'd also highly recommend consulting with. Super insulating brick walls carries much more risk. So when you're going down to U values of 0.16, like John showed earlier on, this is a very risky strategy. I would recommend limiting it to much lower, higher levels of U value as referenced by the guidance in the pilot scheme. Ensure materials are verified by at the very least have a declaration of performance, and also there's full disclosure of the material and performance characteristics. So that is key. Ensuring the materials do what they claim they do, and they have backed up by at the very least a declaration of performance or some form of third-party testing. And a Dublin solution doesn't represent the whole of Ireland, and I say that as a proud Cavan man. So Dublin is a very sheltered climate, but when you go out to Belmullet or go to West Cork or up to Donegal, you have a very different set of circumstances there. So you need to bear that in mind. So really the pilot scheme, it opens the door to assess best practice approaches to sensitively retrofit traditional buildings. And it is a pilot scheme. And it's very much at that stage, it's following the lessons learned from that pilot scheme where we can take on and really roll that out to a broader scheme, as far as I know, and Stephen would be able to give more details on that. So we need to improve town performance of existing buildings, but it's critical to research the overall impact of the solutions and protect our heritage as well. We do provide free training on our website. There is a much more detailed course where the next one is on the 4th of December. Free online training, as well as in-house training and consultation if people wanted to pop by sometime. And there's lots of other readings there at the end of my presentation. Thank you very much. I think I kept it to the 10 minutes thereabouts. Is that okay, Brian?
No problem. Thanks.
That was a whistle stop.
Thanks very much, Niall. That was a very informative presentation. Good case studies as well. It's great to see some of this in action. So again, any questions for anybody attending? marketing@koresystem.com is the email address if you want to submit your questions. I know we're running a little behind on time, but we'll try to address as many as we can. So lastly, I'd like to welcome Barry McCarron from KORE Retrofit. Barry will be presenting on the process of working with KORE Retrofit as a one-stop shop on the traditional homes pilot scheme. So Barry, I'll go ahead and share my screen here.
Thanks, Brian. And thanks to everybody so far for contributing to the. I
think we've lost Barry there for just a second.
Segment of the webinar. Yeah, can you hear me, everyone?
I can, yeah.
Okay, yeah. So what I'm trying to do with the last segment of the webinar here is really to just cover off the one-stop shop and the collaborative approach that we're going to employ for the traditional home scheme. Now, again, if we move to the next slide, I'll touch into really about KORE Retrofit. You can move on from that. So with KORE Retrofit, we were, as Brian said at the start in the initial introduction, the very first one-stop shop established with the SEAI, and moving on from that as well, we're looking to be progressive and to really lean into this new program as well. Hence the webinar today. I'm pulling together the expertise and the collaboration we have with Ecological Building Systems. You can see there an example of one of our more relevant retrofits in this, but across the business annually, you're talking now really, KORE's handling maybe 450 there or thereabouts retrofits in a given year, and that gives an indication of just what expertise we've built up internally in the business and how we're going to be able to springboard into this pilot scheme going forward. So if we move to the next slide, I'll start to maybe take us through what that might look like. And Stephen Farrell from the SEAI has already touched on that. But just before I do, we have, and just to show, that KORE Retrofit is in a real progressive space and is really starting to also, embrace natural materials as, the climate change imperative it stares us down. But also with that, you know, looking with an eye to future regulations and to preserve our business and everything else, we're really involved in the R&D space, and we have a European funded project at the moment called Circular Reno. So circularity identified in that, and also renovation through the word Reno. And what we're doing there is we're bringing together a panelized solution with bio-based materials, and we've already done a project, and you can see it there in the photograph. So that somewhat speaks to our credentials in this space as well. So if we go to the next slide, I'm going to really start then to just really step us through this arrangement now, and the various steps in which will be the process for everybody wanting to come forward on the scheme, both from what is now termed a traditional building professional, which we did get an overview from Stephen. I'm going to touch on it there again, and also the homeowners and the contractors, and that's represented with everybody here on the call. But what's key for us in KORE Retrofit, and what our unique selling point is as well, along with a small community of the various one-stop shops, is that we also are in that space where if you're doing an extension as well as the retrofit, then that's the space that we occupy within the one-stop shop arrangement. So a lot of experience there with the trials and tribulations that come with these projects. So yeah, we'll just head on to the next slide. So of course, you know, we've referred to it, the traditional building professional, or TBP, which we'll see all throughout the various literature that you'll get in the pack after this. So that really isn't exclusive to architects. It is, of course, architects through the form of the SEAI registered architects that have the conservation accreditations. But also in this as well, we have the registered building surveyors and those of that community that have the conservation accreditation there as well. And of course, last but not least, within Engineers Ireland, the registered structural engineers that also have the conservation accreditation. So your traditional building profession can be any one of those three qualifications typically, and we'll be in that space as well. So if we move on, I think it's step one. Yeah, so really step one is how this comes together, and what happens here is, you know, the homeowner might engage with a traditional professionalist. The homeowner very often might come to us, the one-stop shop. Whichever combination comes together, the engagement when it comes to us in the one-stop shop, we'll engage there, and from there we'll step forward. So what happens then around that at the very first step is that the traditional building professional will produce a retrofit plan, and of course that's in accordance with the EN 16883, which we got an oversight from earlier. And also at this point as well, we would liaise, or the traditional building professional would also liaise with building control and conservation officer where that's relevant as well. And you know, again, for the homeowners on the call as well, if you're coming to KORE Retrofit cold and you have a project, we'll do our best to again identify various actors in that space to get the ball rolling. So that's step one. We'll kick on to step two then. So this is now where we really then dovetail back in with the existing one-stop shop arrangement. And again, I do know that the attendance is which is quite large today, is mostly made up of the architectural community. So again, for speaking to them directly, this is how the one-stop shop arrangement typically works. So what will happen at the start then is a home energy assessment, and again, that'll take into account all the various metrics of the building and collate it in along with the BER assessment as well, what the plan will look like for the building. And of course, in this scheme as well, we'll also have the input of the traditional building professional as well, and their plan alongside the building. So that's step two. If we move on to step three. Yeah, so then it moves from that, which will have produced a specification, and then like anything else in the construction industry, once we have that specification, then we're able to move to the next part of the process, which would be really step 3. I'm not going to go through every single point in it just due to time, but these slides will, and the recording will be available afterwards. Yeah. So step 4, once we get the tender back, we will review the assessment and get the quote as well. And it'll cover all the various obligations, payment conditions as well, and cover off insurance, safety there as listed, and the various grant conditions, warranties as well, and then also the legals as well. So that's step 4. And then step 5 is we would then move to appoint a main contractor, and then from that, that's as straightforward as that. But where KORE Retrofit come in here is, again, as a unique selling point, is we would have or appoint internally a project manager for the project, and that's a key offering then as well. And that liaison then happens with the homeowner, the main contractor, and again the architect and the traditional building professional, which may or may not also be the architect on the project as well. And everybody's getting that degree of oversight on this scheme as well. So that's right. And then there's an induction and various bits that will happen there as well. And then the project will kick off and proceed to works, which is the next slide, step 6. Again, if we can, I suppose, close our eyes and visualize then that the works commence, and there's various gates within that as well. One being mid-works, which we would come out again and conduct an inspection along the way, and again alongside this as well, the payment structure would follow these gates as well. So that's really how that works in terms of the works commencing. Yeah. And again, work's ongoing, so it's more or less 6 and 7 is 2 of the same thing in many reasons. As the project sort of comes towards the end, we would be again throughout this process accumulating all the evidence and various photographs and different measurements, key junctions and details. And again, if you think back to John's presentation and indeed Niall's there on the technical, you can see the need for this that in this scheme more than others. So that our processes should dovetail really, really well for this program. So that's works ongoing, and that's step 7. And then we move to the sort of close of the project again. So we're collating then all the various bits of document to close out the project as well. So again, this is typical of many other contractual arrangements, where data sheets, commissioning, declarations of performance, conformance as well, all the manuals, the different certificates, and that really comes together to close out the project, which is, I think, here step 9. So we've truncated it a little bit to bring into play just in a little bit more detail how this would work in reality versus what Stephen showed in the snapshot at the start. If we can get the next slide to move forward. Yeah, so that's just closing out the project. So what happens at the end then really is the declaration of works is signed, the grant works application is closed with the SEAI, the document file is submitted then as well, and the different warranties and inspections are completed. So the key differences then is really this in as a recap, and I know we're a little over time. It's really to just pick up what, and again, Stephen did touch on this at the start. Again, the pilot scheme really is, and you can see from who we brought together today, it's capitalizing on building science along with the correct materials for this project or this scheme, and then with that, we'll get good quality outcomes for high performance and comfort. But one of the key differences to highlight is with the various funding offers that are there, it is around the doors and the windows. There is funding for secondary glazing within the windows. That's a key difference to the original one-stop shop amounts, and this will be in the pack after that gets distributed. So that's the first one. The second one then is really around the U values, and we've seen this coming through in some of the questions before we kicked off today. of moisture or heat, with the vapor permeable materials. So this is an important point. And then also there at the bottom as well, and it was outlined in one of the other presentations as well. Again, if we're falling short of that B2 or 100 kilowatt uplift, there is again a small derogation that would be given there as well if everything else complies. So that's a key difference. Yeah. And then last but not least is and John touched on this as well, around the declaration of works. And again, that's because we're opening up to these other materials, the more breathable materials that are on the market that might necessarily not have the Irish Agreement certification. So that brings us then in line with the declaration of works being signed in accordance with the Irish building regulations, makes everything coherent. Okay, so that's the key differences. That's just to round out on that. Yeah, so that's a thank you from me, and then we'll kick over to Brian and we'll try and address the questions that you might have as well.
Thanks very much, Barry. So we did get a few questions in. I don't think we'll have time to answer all of them today, but we've noted them. We're going to be sending around a post-event recap with a copy of the recording. So one of the questions was, will there be a recording available? The answer is yes. We'll be sending a full recording along with a survey and answers to any questions that we aren't able to address live today. So the first one, I guess for either you, Stephen, or Barry, does the grant, sorry, I just seem to have lost it. How can the scheme work in parallel with the Better Energy Community Scheme and Vacant Property Refurbishment Grant? What specific guidance in terms of retrofit strategy must an applicant comply with?
I'll take that, guys. So the scheme is designed, given the nature of the scheme and I suppose the sensitivities required and the learnings out there across the market that need to be applied when looking at these homes. It's ring fenced to the one-stop shop program. So the expert retrofitters. And we built in that collaboration with the traditional building professionals to manage and control the output of these 100 homes. So it's not, it doesn't work with the Better Energy Homes, Community Energy Grant Scheme, so it's ring fenced to the one-stop shop for that reason alone, and so on. And the second part of that question, Brian, the retrofit strategy.
It was the vacant and derelict home scheme.
Oh, yeah, it can work in parallel with the vacant and derelict home scheme. Just you need to work with the local authority where the home is being upgraded. And I suppose the sense there is that there's transparency in terms of what measures are being grant aided under what program to make sure there's no kind of double funding. So there's full transparency. So the funding coming from SEAI are for specific measures, and the funding coming via the local authorities for, say, the refurbishment of, say, the roof structure or the structural side of things. So there's a clear differentiation between the measures that are being funded, but they work side by side. We get a number of applications coming through and are live on the system at the minute, utilising those two funding streams.
Thanks very much, Stephen. One for you, Niall, then. So this was from a homeowner. Our traditional build house has been deemed unsuitable for wraparound external or internal insulation because the walls need to breathe, as per the assessor. So how can I retain the heat in my home? Would it be eligible for the pilot scheme for traditional builds?
Yeah, I would anticipate that the assessor may not be familiar with the pilot scheme at the time that this question was raised, and there are, of course, solutions appropriate for traditional buildings. I just went through a few today. Really, I would say in terms of the application, if they contacted Barry as the one-stop shop with KORE Retrofit, made the application, went through the process, and then it could verify whether it fits the bill for the pilot scheme. And in terms of the solutions, we work closely with KORE on looking at appropriate materials for the project, and we can look through our suite of solutions. The other thing is we have that training. It's free online on the 4th of December, I think it is. You can look it up online for restoration of traditional buildings. You could sign up to that and just have get more informed as well. So that would be my guidance on that.
Thanks very much, Niall.
Okay.
One for you, John. Been asked, do you have an opinion on the thin skin glazing for traditional windows?
Yeah, I think it can be a very good idea. It depends the conservation nature of the windows. Sometimes you lose the character and impact on the character, particularly protected structures, when you remove existing crown glazing and stuff, where you actually lose the mottled effect. But it can work. There's no doubt about it. But it will only work in tandem with an extensive servicing or repair of the existing sashes.
Perfect. Thanks, John. Another one for you, Stephen, then. Just a question on traditional building professionals. Is there a list of TBPs in the country similar to the SEAI contractor list? And then how much would the professional cost as a percentage of the cost? I'm not sure if that's one that could be answered.
Yeah, no. Well, in terms of the lists, each of the professional institutes, so the RAI, Engineers Ireland, and the SESI would have their list of professionals on the website. And you can go in there and have a look around, and they're graded grade 1, 2, and 3 with respect to the RAI. In terms of the cost, it's kind of a private kind of professional fees based on the type and design and the extensive pre-analysis work and involvement that's required. So you just need to kind of engage and get a sense of it across the market.
Thanks, Stephen. Another one for you, Niall, here. So again, this is a live project. I'm working on an old cottage with stone rubble walls. Is there a cost-effective solution to insulate the existing external walls? It says our client had previously dry-lined these walls, and we were trying to convince them that the solution isn't appropriate. However, the cost for using breathable insulation seems to be very expensive.
Yeah, we'd have to get more details. There isn't a silver bullet solution. I went through a few solutions there earlier, but these buildings are like fingerprints, no two are the same. And we'd have to look at the wall, get more details on the project. And then there are cost optimal solutions. Sometimes, for example, if the wall is stripped back to the bare stone, it's more economic to use thermal plaster to level and insulate. Or if the wall had an existing lime plaster in good condition, then bonding a wood fiber board could be a more cost effective solution directly to that. So, and as well as that, you need to assess the wall, what's most compatible, what is the existing condition, are there moisture issues? That would be a starting point. So I think if they send on details direct to us, we can have a look at the details and come back with some proposals. That's no problem.
Perfect. Thanks, Niall. Barry, you may be able to answer this one, or Stephen. So the question relates to professional indemnity insurance. If I am a self-built applicant who is also an RIAI grade 1 conservation architect, then is there a requirement for professional indemnity insurance?
There would be. Oh, sorry. Go on, Barry.
No, I'll pass to you, Stephen.
Okay. Yeah. There is under the traditional homes program in terms of they're indemnified for the design work that they're carried out in that domestic setting. So yes, we would call for that. Yeah.
Perfect. The rest of the questions I have here, guys, are they're very specific to projects. So I think it might be better if we take those offline and answer them either direct. I can send them to you, Niall or John, and we can get those answered offline. Just recognizing time as well. Barry, did you want to close off the session today?
I'll wrap up, Brian. Thank you. Yeah. So just sort of as we do come to a close, I've referenced it a couple of times there. We're delighted with the attendance. We had over 500 people registered, and I think they're at the highest point. We might have had 363 or something live, which is fantastic. Really does show the amount of pent-up interest that there might be in this scheme. We did curate today's session to really try and address a lot of the questions that we've sort of seen coming across the bow in the run-up to the event. But we are putting together a pack on the other side of this as well for everybody that has registered. And considering it's such big numbers, we've already put a bit of time and thought into that. So it'll be a comprehensive package that will sort of complement everything that you've heard today. So hopefully everybody will enjoy that. moving on then as well, hopefully as well, the doors are open, both with ourselves, KORE Retrofit, Ecological as well, and again amongst the architecture community, and indeed now this new term, traditional building professionals, and their lists, as Stephen has outlined, are up there as well. So hopefully we'll get a melting pot of engagement now on the other side of this as well. And I think as well, we've maybe provided a bit of confidence to this whole community as well, that there is, you know, a very coherent, you know, educated this is the pilot. It's not the full end finished product. So, you know, we've all sort of committed to viewing it positively. I'm sure like anything we can pick holes in it, but it's all about learning across these first 100 homes, and hopefully you know, we'll hit the first 100 homes as soon as, and we'll get those lessons deduced and factored in. So really it's just a big thank you for everybody who's come along today. A special word of thanks to Wain Morehead, who is under the weather. I don't know if everybody picked that up maybe, but he really was struggling. So big special thanks to John, along with Stephen and Niall, and indeed Brian and our own team here as well. And we just look forward to hearing from people, and you know, supporting everybody in the scheme, and of course answering questions as well as you go forward, and together we'll be able to, you know, really improve these homes and buildings which we all treasure, you know. So that's a sign off from us, and yeah, thank you everyone.
That's great.
That's great. Thanks everybody.
Thanks
Thank
guys.
you.
All the
Thanks
best.
everyone.
Take care.
Bye bye.
Bye bye.